Welcome back. So in this video, we will be discussing on maxima and minima of a function. Maxima and minima of a function. Okay. Consider a graph, something like this. Okay. So this is very useful when we discuss about the gradient descendant. So consider a graph. Okay. Consider a graph, something like this. Okay. Here we know that the minimum value is something here, right? And if the graph is something like this, okay, so here this will be the maximum value, right? And there are some graph maybe something like this, okay, if we are some points are there, if it is what we called a something like a sine wave kind of a thing, right? Sine wave kind of a thing, something like this. So here we can see that it has a multiple maximum values and multiple minimum values, right? So this may be a, I mean, local minimum value. This will be a local minima. This may be a, we will call it as a local minimum, okay, by considering this particular portion. And this may be a local maximum. This may be a local maximum point, okay. And there are some graphs maybe there something like this, okay. Here we can say that some graph may go like this, okay. And here we can say that this is the global minimum point, okay, and this is the local minimum point. So local minimum point is with respect to this particular portion, this is the minimum, okay. So by considering entire function, this will be the minimum point, okay. So the question is, how can we calculate this, okay? So there is the methods, there is some defined method to calculate the maxima and minima of a function, okay. So for that, what we will do, let me write the steps first. First, calculate the differentiation of, calculate, okay. Okay, so let me write it again. Second, consider a function f of x. Consider a function f of x, okay. So in that case, the first step, what we will do, we will calculate the first derivative of f of x, okay. You can write it as calculate first derivative let me correct it. Calculate first derivative, okay. First derivative of f of x, okay. Then the second point is equate the first derivative of f of x to 0 and calculate values of x, okay. Now the third point is calculate the second derivative of x, that is equal to the f dash of x means calculate second derivative of f of x, okay. Then what we need to do, okay, so we need to see the second derivative value, that is if second derivative of x, we have to apply these values of x, right? So here we have found the values of x, right? So if f double dash of x is greater than 0, then we will consider it as a local minimum. Then we will consider it as a local minimum at point x. Okay, and if f double dash of x is less than 0, then it will be local maximum at point x. Now the third condition is f double dash of x equal to 0, then this may be either max nor min value. So this, if f double dash of x is 0, that is we call the inflation point, or it may be a saddle point, because it is, we cannot able to find the minima or maxima at this particular point, at this point x, at the point x is equal to 0. Sorry. And if f double dash of x is equal to 0, this is a saddle point, maybe a saddle point, then there will not be any maxima or minima value there. Okay, so we can do a example. We can try to see a function, and we can try to figure out the maxima and minima of a value. Okay, then this will be more clear. I know just saying the theory part will be little difficult, but consider a function f of x which is equal to 12x raised to 5 minus 45x raised to 4 plus 40x cube plus 5. This is 40. Okay. Okay. So the first step is we need to calculate the first derivative of x. This can be 12 into 5 into x raised to 4 minus 4 into x cube. Sorry. Let me correct this. Just a second. 4 into x cube plus 40 into 3 into x square plus 0. Okay. Derivative of a constant is 0. So this will be 60 x raised to 4 minus this. So okay, there is a mistake here in the question. This is 45 x raised to 4. Okay, this is 45 x raised to 4, and this will be 45 into 4. Okay, so this will be, you can say it as 180 x cube plus this is 120 x square, right? And here what we can say, we can take 60 x square as a common thing. We can see the x square. This will be x square minus 3x plus 2, right? 2. Okay. Now what we can do, we need to equate f of x to 0. So that means we have like 60 x square into x square minus 3x plus 2, which is equal to 0. This I can make it as something like this: 60x square plus x square minus x minus 2x plus 2, which is equal to 0. This will be 60x square into, can write it as this is x minus 1 into x minus 2. We can solving this, we will getting this. So here what will the different values of x? X equal to, we can say that 1, and x equal to 2, and then next will be x is equal to 0. Okay, so these are the values of x. Now what will be our next step? Let me add few pages here. So next step will be, we need to calculate the second derivative, right? So here let me calculate f double dash of x. Okay, this will be equal to let me check the first one. Okay, this is 60x raised to 4, right? So we can say that 60x raised to 4, which is equal to 60 into 60 into x raised to 4, that is 4 into x raised to cube minus 180 into 2, right? 180 into 3x square. You can say 180 into 3x square. Okay. Then the last one is 120 into 2x. This will be plus, right? Plus 120 into 2x. 120 into 2 into x. So this will be, we can say that 240x cube, right? Minus, this will be 540 x square plus 240x. This is x. 240x. Okay. So this is f double dash of x. Now just calculate f double dash of 2. Okay. So this will be 240 into 8 minus 540 into 4 plus 240 into 2. This will be, I can say that 0 to 1920 minus 0 6 2160 plus 480, right? So first we can add 1920 maybe plus 480. This will be 0 0 10 4 2400. Okay, then 2400 minus 2160. I can simply use the calculator, but yeah, for this is some around 240, right? So we can say that f double dash of 2 is equal to 240, which is greater than 0. Okay, so that means the x is equal to 2 will be the local minima. This is as per our rule. Okay, if f double dash of x is greater than 0, then it will be a local minima. So we can see, now we can see f double dash of 1. Okay, so this will be equal to 60 into 60 into 1, right? Let me check this, just a second, I forgot this. 240x cube, right? Yeah. Let me correct it. Just a second. Here we can say that 240 into 1 minus, I believe it is 540. 540 into 1 plus 240. So this will be equal to 240 plus 240, which is equal to 0.84, right? So we can say that which is equal to, we can say that 480 minus 540, which is definitely less than 0, right? So if double dash of 1 is less than 0, then this will be local, this point will be local maxima point, local maxima point. Okay, so at x is equal to 1, this will be the local local maxima point, and x is equal to 2 will be the minimum point. Then we have one more point is there, that is f double dash of 0. When x is equal to 0, we know that this entire term will be 0. So this is neither maxima or nor minima, right? Okay, let me correct it. This can be considered as a inflation point. So this will be a inflation point. Okay. So there is one more thing we need to do. So here we know that at x is equal to 2, this will be maybe local minima, right? X is equal to 2 will be the local minima, and x is equal to 1 will be the local maxima, and x is equal to 0 will be a saddle point or inflation point. So we can see that f of x equal to 2, we can apply this to the function, then it will be 12 into 32 minus 45 into 60 plus 40 into 8 plus 5. So this can be, the function point will be minus 11. Then at x is equal to 1, we can say that this will be the point 12 minus 45 plus 40 plus 5. So this will be cancelled, and this will be 12. Okay. So these are the things like I want to discuss in this video. So here what we have done, we have discussed about local minima and maxima, and how can we calculate it with respect to first derivative and the second derivative, and we will be equating the first derivative to 0, and we will be calculating the x values with respect to the first derivative. Then we will be calculating the second derivative, and we will be applying these x values in the second derivative, and if the second derivative is less than 0, then this will be considered as a, if less than 0, then it will be local maxima point. If greater than 0, this will be considered as a local minima point. Okay, and if f of double dash, that is second derivative f of x is 0, then we will say that it is an inflation point. There is no maxima or no minima value. Okay, so here what we have done in the last step, we have given this x value. Okay, so this x value to our original function, then we calculated those points. Okay, yep. So that is all about in this video. I hope everybody understood this particular maxima and minima concept. Okay, bye bye, thank you.